Hi students, just now we derived an expression for what the final velocity v1 and v2 in the case of one-dimensional elastic collision, isn't it? Now based on that we are going to discuss some special cases. So what are the special cases? For example, let us take the first case. In the first case, I will take both the colliding bodies are having equal mass. So I will take m1 is equal to m2. In this case, what will be the final velocities v1 and v2? So in the first equation, v1 is equal to u1 into m1 minus m2. So m1 minus m2, instead of m2 if you substitute m1 because they are equal mass, plus 2m2, okay, 2m2 into u2, and the denominator is common, m1 plus m2. So this is m1 plus m1 because both are same mass. And here I will substitute m2 plus m2, both are one and the same. Like this also we can write, okay. So this will become 0 because m1 minus m1 is 0. So v1 will be equal to 2m2u2. So this is equal to 2m2u2 divided by m2 plus m2 is 2m2. So 2 and m2 get cancelled. This implies what? v1 is equal to u2. So the final velocity of the first body will be equal to the initial velocity of the second body. Understand that? Now, what is the expression for v2? So what is v2? This is u2 into m2 minus m1 can be written as what? m2 minus m2 itself, because m1 is equal to m2 plus 2m1u1. So this is 2m1u1 divided by, here I can substitute the m1 plus m1, and here I can substitute again m1 plus m1, so that this will become 0, and the second term only will remain. m1 plus m1 is what? 2m1. So 2m1 also can be cancelled. Therefore what do we get? v2 is equal to u1. So here we have shown that the final velocity of the second body is equal to the initial velocity of the first body. So the reverse of the first case, isn't it? So from this, what do we understand? When two bodies of equal mass will collide with each other, their velocities are interchanged. And this is very, very important in the field of physics. See, in the nuclear reactors, when uranium is bombarded by a slow neutron, 3 neutrons, or on an average 2.5 neutrons will be released in each fission reaction. So some of them will be fast neutrons, isn't it? So we have to control their speed. So how is the speed or kinetic energy of the fast neutrons be controlled? Is by using a material called a moderator, which is rich in protons. So here children, suppose if you take a proton and a neutron, if they are colliding with each other, they will interchange their velocities like this. They will interchange. So this action only is called as moderation. So in the case of moderator in a nuclear reactor, okay. So this application is involved. Now we will go for the case 2, okay. So the second case. In this case also, I will take m1 is equal to m2, and the second body is at rest. Say for example, the second body is at rest, means u2 must be equal to what? 0. In this case, so sometimes what will happen? A vehicle will be parked on the side of the road. Another vehicle coming very rashly may hit with the resting vehicle and it gets stopped. The resting vehicle may pick up its speed and go forward. So these are all happening in everyday collisions, isn't it? So I will take both the bodies are having equal masses and the second body is at rest, let us say. Okay, in this case I am going to substitute for V1 first. So what is V1? V1 is equal to U1 into m1 minus m1 divided by m1 plus m1 plus 2m2 u2. So 2m2 into u2 is 0 and divided by m1 plus m2. So m1 minus m1 also is 0. Second term multiplied by 0 is also 0. Therefore, what is v1? v1 is equal to 0, which is equal to the initial velocity rest. Is it not that? So it is an extended case. The previous case is extended by taking u2 is equal to 0. Similarly, what will be now v2? v2 is now equal to u2 into m2 minus m1. So this is m2 minus m2 because m1 is equal to m2 divided by m1 plus m1. Okay, or m2 plus anything you can substitute because the numerator is 0 plus 2m1. So this is plus 2m1 u1 divided by m1 plus m1. So this is m1 plus m1. So the first term becomes 0. So v2 is now equal to 2m1 u1 2m1 divided by 2m1. Okay, so 2m1 get cancelled and this implies what? v2 is equal to u1. It is again similar to that of the case 1 itself. Understand that? So these are the two very important cases. Now the third case we are going to discuss. So I am going to erase case 1. So this case 1 you must have understood well. So what is the case 3? Let us take. In this case, I will take mass m1 is very much smaller than m2. Very much smaller than m2. Say for example, a ball is rolling on the floor and it is going to hit with the wall. Wall is the second body. So if you compare the mass of the ball, the mass of the wall is very much greater. So what will happen if the ball is colliding with the wall? After collision, what is going to happen? It will return back along the same straight line but in the opposite direction. Is it not? So this is going to happen in case 3. So m1 is very much less than m2. Also the second body, say for example wall, it is at rest. The second body is at rest. In this case, I am going to substitute for v1 at v2. So first what is v1 equal to u1. So this is u1 into, as usual, I will write m1 minus m2 divided by m1 plus m2. Okay, plus 2m2 u2 divided by m1 plus m2. Okay, now I will divide the numerator, each term, numerator term. Now I am going to divide by m2. So this is also equal to u1 into m1 by m2 minus m2 by m2. So this is m2 divided by m2 plus 2 into m2 by m2 into u2 divided by m1 plus m2. Okay, so that now this is equal to u1 into m1 by m2. So this is m1 by m2 minus 1 plus 2 into m2, 1, that is m2 by m2 is 1. So I can write 2 into u2 divided by m1 plus m1. Already I will divide this also by m2, is it not? So this is m1 by m2, this also is divided by this. So m1 by m2 plus 1. Okay, so we have assumed that m1 is very much small comparing to m2. Therefore m1 by m2. So m1 by m2 must be very much smaller than 1 or it must be nearly equal to 0. So if you divide the mass of the small ball by the mass of the wall, it is nearly equal to 0. So m1 by m2 must be nearly equal to 0. So wherever m1 by m2 is coming, it is taken as what? 0. Okay. So now therefore v1 must be equal to. So this is u1 into 0 minus 1. So this is u1 into 0 minus 1 is minus 1 plus second body. Here also second body is at rest, no? So second term will become 0 divided by m1 plus m2 is 0. So this is divided by 1. Therefore v1 is equal to minus of u1. I told you no. Suppose if a ball is rolling with the initial velocity u1, it will hit with the wall and rebound with the same magnitude of the velocity in the opposite direction. So the final velocity of the ball must be equal to negative of its initial velocity. Understand? Similarly, now you get an expression for v2. So v2 is now equal to u2 into m2 divided by m2 minus m1 divided by m2 plus 2 into m1 by m2 into u1 and this is a whole divided by m1 plus m2. So this is m1 by m2 plus m2 by m2. So that this is equal to u2 into m2 by m2 is 1 and minus m1 by m2 is 0 plus 2 into this m1 by m2 is 0. So 2 into 0 divided by this is m1 by m2 is 0. So 0 plus m2 by m2 is 1. So that this is now equal to what? u2 into 1. So this is u2. Therefore v2 is equal to u2. What is actually the case? We have assumed u2 is equal to 0, is it not? So this also implies that v2 is equal to u2 is equal to 0. So the first body is the ball, second body is the wall, is it not? Because of the colliding ball, the wall is not going to move anywhere. So its velocity will be 0. After collision also it will be 0. Understand? So children, now we have discussed 3 special cases, out of which the first special case is very important and it is used in the case of nuclear reactors, in the case of moderators. So moderator is a substance which is used to reduce the kinetic energy of the fast neutrons to thermal neutrons or slow neutrons, so that there is an exchange of energy between the protons and the neutrons. So the other 2 cases in everyday collisions they are applied. I hope you must have understood this well. Fine.